There's probably 20 full curators in the United States at any given time, and to be one of the lucky few, it's inspiring. I never planned to work on the evolution of venomous fish. I never planned, to get into certain aspects of what I do, but sort of happenstance or nature just sort of dragged me kicking and screaming to work on venomous fishes. When I was a college student working at a pet store, someone had thrown away a fuzzy dwarf lionfish into the trash. And so I went to grab a phone back when phones were still connected to walls in the mid-1990s. And the receiver went into the trash can. So when I went to go grab the receiver out of the trash can, there was a dead lionfish in there, and it stabbed my hand. I sort of passed out. The pain was really intense. Because the fish was dead, the venom had actually escaped the venom glands, and so that it actually probably got a stronger dose. It was sort of loose all over the place. At that point, I actually went to the library, because it was sort of pre-Google, and tried to look up what fishes were venomous. And this fish wasn't listed as venomous, but that was sort of crazy to me, since it was obviously a lionfish, and why wouldn't all lionfishes be venomous? So then it became, well, what do we know about all the other groups? This is the best known group. We did a giant tree of how all fish are related, and took known specimens that were known to be venomous at the actual species level. So we took the tree, made a giant tree from the bottom up, and then anatomically actually took specimens from the collection and looked for signs of the venom gland. So we knew that the lionfish was venomous, so how sort of working our way down the tree as we go from one generation back, another generation back. From that, we were able to identify all the venomous fishes in the world, and so instead of having a number that was close to 200 or 300, we were able to come up with an estimate that was more like 3,000 or 4,000 fish. One of my main aspects of my job is a curation of the collection itself, but we're basically a librarian for fish specimens that go all over the world, people come here to look at. With the case of evolutionary history, what you're doing is you're taking all these nuggets of information that you know about a fish, like whether it breeds like this, or whether it lives in this kind of water, or whether it's venomous, and you're putting it in, you're categorizing it in the way that it actually evolved. So it's the most concise way of storing the information about all life on Earth. The work that I'm doing at the Field Museum fits into systems biology in the sense that I almost always start at the organismal level. So I have a lionfish, I have a stonefish, but instead of working my way up in systems biology, I start diving down. And so a lot of people at the Field Museum could dive down to DNA sequences, because that's sort of the heritable portion that we can use to generate trees of life. I like my job because it's like a puzzle. Figuring out how fishes are related to each other, or any animals are related to each other, I like almost as much as the fishes themselves. My name's Leo Smith, and I'm trying to solve the puzzle of how fishes are related.